There we go.
Oh, sorry, you don't get this.
Oh, yep, that's for you.
That's for me.
Yep. Yeah, oh, and then I've got a spare one here for Shreya, so. All right, so chapter 6, I said, like, try and have a go at it over the holidays if you can. Some of you expressed concern with 6C.2. Don't worry about that so much if you found it challenging, because it will pop up again throughout chapter 7. I also do have a video I can send you if you do want to go back and perfect it. So chapter 6, my assumption is you've done it. I'm not going to check. It's just a lot of background stats information. So that means our next test is on just chapter 7. It's discrete random variables. We have binomial distribution in it. It is commonly the easiest test. So we can expect, you know, some good results here. And it's a short, sharp, shiny unit. All right, so just chapter 7. Then what we'll do this term is we'll break, we'll go do some integration. So that'll be chapter 4 and 5. And then we'll keep this booklet for chapters 8 and 9, which we'll do in term 3. Okay, so let's get straight into what we're talking about then. We have random variables. So let's have a read of our notes and then we'll make some assessments here about the difference between them. We have a random variable uses numbers to describe the possible outcomes which could result from a random experiment. Random variables are either discrete or continuous. Discrete variables take whole integer values. These are things that you count. For example, how many goals scored in a game of soccer. These are whole integer values. You don't have half a goal or a third of a goal. Or the number of cows in a field. Okay, so we have whole cows in a field, regardless of their size. Okay? Continuous random variables exist on an interval. They are continuous. These are things that you measure, all right? When you measure the height of someone, how tall a year 12 is, there is a whole spectrum of length it can cover. So, you know, someone could be 178.1479 centimetres, or the time taken to run 100 metres. We can divide time up into an infinite number of intervals as well. Okay. Question 1, state whether the following are discrete or continuous. So this will just be a bit of a discussion for us. We have the number of players on a soccer team. It's something that you count, so that's going to be discrete. Very good. The distance from school to your house. Something you measure, so it's continuous. The number of pencils in a pencil case, discrete. The number of cars in the car park, discrete. The time it takes to drive home from school. So again, this is something you measure, so continuous. The width of a TV, something you measure, continuous. The amount of pages in a book, something you count, discrete. Okay, really good. So we have a dice is rolled to produce some variable x. So we use capital X to denote some random variable that's occurring, okay? Explain why x is a discrete random variable, okay? All of the outcomes are whole integer values. Now that word integer, or integer, as some people say, integer is correct pronunciation, that just means a whole number. All right. So that's part A. Part B, state the possible values of x. So the way we would do this is we use brackets to describe the distribution space. When you roll a 6-sided die, which it didn't stipulate, but dice come in all shapes and sizes, most commonly a 6-sided dice. All right, and so we dictate the sample space with a bracket, and we're saying those are the possible events that can occur. So we have part A and part B. All right, then we have question 3. We have the length of a student's hair is measured. Okay, is x discrete or continuous? Something you measure. So for 3A, it's going to be continuous. Continuous. Part B, state the possible values of x. So who's got the longest hair in the class? It's not me.
Well, it's Ella because the rest of us have it in buns.
Okay, so Ella, what do you reckon, 50 centimetres?
Sure.
So we'll go from 0, that's me, to 50. All right, so that's the possible. Notice how it's an interval. Continuous data occurs over an interval. Discrete data takes whole integer values. You can't roll a 1.5 on the dice. Okay, that's it. So 7A, let's steamroll that exercise.